Here, in case of collinearity, suppose if 3 points are given, whose position vectors are A bar, B bar, C bar, then there exist some real numbers x, y, z, which are all not simultaneously zeros, are existing in such a way that x A bar plus y B bar plus z C bar equals to 0 and x plus y plus z equals to 0. Here, in addition to this one, we are getting extra condition x plus y plus z equals to 0 for collinearity case. Here, we have almost similar condition even for coplanarity of 3 vectors also seen here. Here, 3 vectors are coplanar, then we get the condition, this one. Second one will not be applicable for this, may or may not be, we don't bother about that one. But in case of collinearity, we have to take x plus y plus z is equals to 0 also. Even yesterday I have given the complete proof of this one. It's a necessary and sufficient condition. Both the ways, if the points are collinear, we get this condition, and vice versa. If the condition is satisfied, then the vectors are collinear. So here, based on this, also we can expect some questions which can be asked sensibly here. Just randomly to get a complete idea how we are using this particular result, here randomly we pick up 1 or 2 cases. Here for example, just we select a triangle ABC is a randomly chosen triangle in which O is a point. It's not origin, O is a randomly chosen point, maybe interior or exterior, doesn't matter here. Now, the vectors AO, BO and CO extended are intersecting the opposite faces at D, E, F respectively. Now, here we have to show that OD by AD plus OE by BE plus OF by CF, sum of these 3 ratios is equals to 1. Like this sensibly can be tested by using our collinearity property here. By using collinearity property, we can get it in better way. Now let us see how to get the proofs of this type of questions by using our result. Now, for a convenience, I am taking this ABC triangle in which O is some internal point. For your better understanding, I am taking it, need not be actually. Now, if you observe in the diagram, this OA bar and OD bar, OA bar, OD bar are lying in the same line with opposite directions. So these 2 vectors OA bar, OD bar are collinear vectors. That is why we can express one vector in terms of others. That's why here I am writing it as, let us take OD bar equals to some minus x into OA bar, where x is taken as positive. Here x is taken as positive now. Here why I am taking minus x into OA bar, this minus indicates that these 2 are unlike vectors, opposite direction vectors. So I am just assuming this particular point in this, rest of the things we can follow as usual now. Now, in this here, these 3 vectors OA bar, OB bar, OC bar are coplanar, lying in the same plane here. That's why there exists some element scalars such that L OA bar plus M OB bar plus N OC bar equals to 0. Coplanarity condition I am using here. A, B, C, OA bar, OB bar, OC bar, 3 vectors are coplanar. Because these 3 vectors are coplanar, there exists some element scalars satisfying this linear dependent condition here now. Now, L into OA bar in this we have taken just now, OA bar is minus 1 by x into OD bar. Replace it with that one, minus 1 by x OD bar plus M OB bar plus n OC bar equals to 0. With simple change, the equation has been converted into this way. Now just observe here, OD bar, OB bar, OC bar are position vectors of D, B, C respectively. D, B, C. But here B, D, C, all the 3 points are lying on same straight line. These are all collinear points. So if the 3 points are collinear, already just now we have discussed the condition also, there exists three scalars like this, x OA bar plus y OB bar plus z OC bar equal to 0, and x plus y plus z is also equals to 0 will come. Applicable only for collinearity case. That's why, because D, B, C are collinear, then we get the condition minus L by x plus m plus n equals to 0, or simply here we get L by x equals to m plus n, then x equals to L by m plus n condition will come. So we are proving that x equals to L by m plus n. Now OD by AD if you are taking, OD by AD if you, because you require this one, OD by AD, similarly we get the rest of the two also. If we are getting one ratio, similarly we can write other two also. Now OD by AD equals to this vector OD bar taken as minus x OA bar, its modulus length we require AD. Now AD, this AD is AO plus OD. Why don't you write AD as AO plus OD? Now here AO, OA bar is A bar, AO will be minus A bar, and OD is minus x OA bar. So minus OA bar minus x OA bar. Here because we have taken modulus and x is positive, so x into mod OA bar by 1 plus x mod OA bar will be coming. These two cancel, minus also cancel because it is inside of the modulus. Now finally we are getting x by 1 plus x. OD by AD ratio is x by 1 plus x, but already we got x value here, substitute back. L by m plus n divided by 1 plus L by m plus n is equals to, we are getting L by L plus m plus n. And you can guess very comfortably, if this value is L by L plus m plus n, then this will come as m by L plus m plus n, and this is nothing but n by L plus m plus n. Adding all the three, denominator is same in all, then numerator is L plus m plus n, these two cancel, the result will come as 1. We can show this very comfortably like this. So this is the advantage of our collinearity property in solving such sensible questions. Okay, here that is why just every time I am focusing some sensible areas to be focused in this final moment, and what type of questions you can solve by using these areas. That's what my intention in this revision part here. So this is the solution for this. If you want the better clarity, even I can give you one more example. Let us pick up one more simple question. Now instead of taking a triangle, let us go with a parallelogram. Here just pick a parallelogram OABC. Let us assume OABC as a parallelogram with one of the vertices as origin. Now a transversal, randomly chosen a transversal, suppose intersecting OA, OC as well as the diagonal through O, all these at some L, M and N, intersecting at these points. Then we have to show that OA by OL plus OC by ON, OA by OL, OC by ON equals to OB by OM. Either this problem or previous problem seems to be appear as if they are nowhere connected with vector concept. They are given, questions are framed in scalar concept, but we can get the solution much effectively by using vector concept. That too collinearity concept we are applying here properly. So this is also one more example which can be solved by using previous example. Now let us see how to solve this one. Here this is randomly chosen transversal, I said. Now OL and OA are collinear vectors. Now let us assume this OA, vector OA bar equals to some L into OL bar, L some constant, because these two are collinear vectors, we can express one in terms of other some lambda. L is some constant, randomly chosen constant. Now OB bar equals to some M into OM bar and OC bar equals to some N into ON bar. We are assuming this step in the first here. Now it is a parallelogram. In parallelogram we know that vector OA bar plus vector AB bar equals to vector OB bar. OA bar plus AB bar equal to OB bar. Here OA bar, we can write OA bar as L into OL bar plus this AB bar and OC bar are same in parallelogram, opposite sides. AB bar is replaced with OC bar and OC bar is equals to N ON bar equals to, this is OB bar is some M into OM bar. Is it clear all of you? Now L OL bar plus N ON bar minus M ON bar equals to 0, we are getting 0 bar. Here how is this relation, try to recollect? Is it in the form of X OA bar plus Y OB bar plus Z OC bar condition or not? At the same time try to recollect here LMN, this is OM, sorry. Now this LMN are collinear points in the diagram clearly showing here. If these 3 points are collinear, then automatically sum of their coefficients also 0 will come. So we are getting L plus N equals to M will come. L plus N equals to M, there ends our solution here. Just observe what is L in this. OA bar equals to L into OL bar you are getting, then L will be mod of this by mod of this. If you apply modulus, their lengths will come. So L is nothing but OA by OL, OA by OL plus N is ON by OC by ON equals to OB by OM. Is it the required proof or not? So in such a simple way we can show this by using our collinearity conditions. Many more we can try by using this special condition collinearity property. So whenever the problem arises we can discuss back this property once again. So here so far just we have focused on 6 important synopsis points to be focused at this final phase of the revision, and each synopsis point is very important, and most of the problems, as I said, clearly more than 90% of the problems of this first part of vectors can be solved by using these 6 simple points, and already all the 6 points we have discussed in previous classes. So once recheck all these earlier discussed points, go through and start doing the problems in proper application with these points now onwards. You can enjoy really, I promise that one. And apart from this, sometimes rarely you may expect some length related in triangles also, and of course that is expected in properties of triangles also, but anyway we are doing in vectors also, in 3D also that comes. here very frequently finding one more concept is angular bisector concept. So at this moment, let me recollect that point also here, how to find the directions of angular bisectors in a triangle. Or if two vectors are given, in random directions, how to trace out the direction vector in the direction of angular bisector, that may be internal or external angular bisectors. So here, now I am choosing two vectors, A bar and B bar. Let us take A bar, B bar, two randomly chosen vectors in different direction. They are not collinear, okay, so that we can form some angle between them. Now express these two vectors as co-initial vectors. Initial point should be same. So what I am doing now, I am taking OA as A bar, and in this direction I am taking OB bar. This OB bar is vector B bar. So here let us take angle between these two as some theta. Now we have to find out the angular bisector of this two vectors. What will be the direction of this one? Okay, so to find out this one, what I am doing now, in the direction of OA, just I am picking a point, some x, which is exactly at a distance of 1 unit from origin. So this OX bar vector, can you guess? It is in the direction of A bar, whose magnitude is 1 unit. So why don't you write it as A cap? Already you know the symbol of cap. A cap indicates unit vector in the direction of A bar. Similarly, pick up one more point y on vector OB bar at a distance of 1 unit, then OY bar will be nothing but B cap will come, because it is a unit vector in the direction of B bar, and OX bar is A cap. Now join x and y, join this x and y. Here OXY, in triangle OXY, so try to recollect what type of triangle is this now. OXY triangle, in this, length OX, length OY both are equal to 1. So clearly it is an isosceles triangle with OX and OY equal. If these two sides are equal, then these two angles also equal. And if you are drawing median through, vertex O, because it is isosceles triangle, this median also acts as angular bisector, even altitude, everything will be same for this particular one. That's why this angular bisector also acts as median now. If you take this median intersecting this xy at C, then OC bar, this OC bar acts as median, angular bisector, even altitude, etc., everything here, because it is an isosceles triangle. Now the angular bisector is nothing but the angular bisector of A bar and B bar is in the direction of OC bar. Therefore OC bar, but is it the position vector of midpoint of x and y or not? It is the midpoint of x and y. So OX bar plus OY bar by 2, midpoint formula applied. But OX bar is nothing but A cap plus B cap by 2. That's all. So clearly if A bar, B bar are two vectors taken in different directions, then sum of their unit vectors divided by 2 is getting back as angular bisector vector. And after all, we require what here? We require clearly the vector direction, not the magnitude. Half decides only its magnitude related. That is why here simply neglect this one. Angular bisector is in the direction of A cap plus B cap. Half only decides its magnitude. I am doubling this magnitude, makes nothing difference. So angular bisector of A bar and B bar will be in the direction of A cap plus B cap. So, this is about angular bisector. If you want suppose 17 units length of angular bisector is required in solving a problem. If you want 17 units, first we divide this angular bisector with its magnitude, then we are getting unit vector in this direction, multiply it with 17, you are getting angular bisector of length 17 units. So, this is the advantage of having one more important point in solving many problems. Okay. So, that is why I am putting this as one more important point in this, so that maximum points in synopsis required for the first part of vectors is been discussed here. Now, in the coming class, next class, I will discuss briefly in in a nutshell about the main points of all products, dot product, vector product, triple products, multiple products. Briefly in a nutshell, I will complete them, then immediately we can switch over to the problems of previously tested mains as well as advanced MSET problems. Okay. So, that is enough today. Tomorrow I will continue